All right. Ready to dive into a pretty crucial moment for the U.S. space program. We're talking Gemini 5. You flagged this one, and for good reason. This wasn't just another hop above Earth, was it? This was a big test, a test for something even bigger, a trip to the moon.
Yes, absolutely. If you look at it chronologically, Gemini 5 stands out. It was the third crewed Gemini flight, 11th for the Americans overall, 19th human spaceflight globally. But this one was ambitious.
It was August 1965, the goal, an 8-day flight. And they weren't picking that number out of a hat. 8 days, that was the estimated time for a lunar mission. Land on the moon, come back home. High stakes. And you've already mentioned the crew, haven't you? L. Gordon Cooper Jr., the command pilot, on his second and last space flight. A pretty big deal. The first person to orbit Earth twice. And then we've got Charles Pete Conrad Jr., first time in space.
Exactly. Yeah. And let's not forget the backup crew. We're talking future Apollo names, people like Neil Armstrong and Elliot C. And the support crew, well, that included Buzz Aldrin, Gus Grissom, James McDivitt. These missions, they were a real team effort, a lot of talent there.
A proper team effort, no doubt. But you mentioned the main aim, 8 days, twice as long as any American had been up there. So the question is, could they do it? Could they prove that humans could actually survive, operate for that long up there?
They did. They achieved that 8-day goal, and that meant they beat the record the Soviets had set with Vostok 5 back in '63. But just to be completely accurate, the mission was cut a little short. Hurricane Betsy, as it turns out, played a part in that decision.
So weather back on Earth influencing things in space. Interesting. Now, how did they even make this extended flight possible? I heard they had some new tech on board.
It's exactly right. The game changer here was the introduction of fuel cells. It was a huge leap, not just for Gemini 5, but for the whole Apollo program. Since the old chemical batteries they used before, these fuel cells made electricity by combining hydrogen and oxygen. Much more sustainable, much longer lasting, crucial if you're going to spend 8 days, let alone travel to the moon. These fuel cells on Gemini 5, they were a direct ancestor of the ones they used in Apollo for the command module and the service module.
So a big step forward technologically. But it wasn't all smooth sailing with these fuel cells, was it?
You're right. Early on, just about 4.25 hours into the mission, they had a pressure drop. Big one, in one of the fuel cells.
Yeah.
Cooper, understandably, decided to shut them down. A bit of a heart-stopping moment, I imagine, because without the fuel cells, the mission was in jeopardy. They needed those for the planned rendezvous, for everything, really. But this early problem, it ended up being a really valuable lesson. It showed just how sensitive these new systems were. They needed better monitoring, more backup systems, all things they learned for future missions. That's aerospace development, isn't it? One step at a time.
Hey, Vince, that's a close call. So what happened next?
Well, the ground crew, they scrambled. Ran a bunch of tests, thankfully. Sure, the fuel cells could still work, even at that lower pressure. So they switched them back on, very carefully, gradually increasing the power. Thankfully, they held. Mission could continue. But I've read that later on they had another issue. The fuel cells were creating a lot of acidic wastewater, more than they expected, about 20% more. They were concerned about their drinking water supply, though they had enough in the end. And then there was another odd thing. The drinking water the fuel cells made, well, it was full of gas bubbles. Not exactly a luxury cruise, I imagine.
Not exactly, no. So you mentioned a rendezvous, one of their objectives. What was the plan there, and how did those fuel cell problems impact it?
The plan was to rendezvous with what they called a Rendezvous Evaluation Pod, or REP for short. This was a small, uncrewed satellite, basically a target for the Gemini spacecraft. They needed to practice docking procedures, very intricate maneuvers, all essential stuff for future missions, especially if you're planning to have the lunar module dock with the command module after a moon landing. And this REP, they launched it early on, about 2 hours into the mission, on the 21st of August. It separated at about 2 meters per second. But then those fuel cell problems cropped up.
So did they even attempt a rendezvous?
Not with the RAP itself, no. The power supply was uncertain. A proper rendezvous was just too risky. But Buzz Aldrin, clever chap, came up with a solution. What they called a phantom rendezvous. Basically, they maneuvered the Gemini to a specific point in space, as if the RAP was there. No physical target, but it still allowed them to test their maneuvering skills, practice their precision, all valuable data for future docking procedures. As for the REP, it fell back to Earth on the 27th of August.
Brilliant improvisation. So beyond the 8 days and this phantom rendezvous, they had a whole list of experiments, didn't they? Science, even military experiments. How did they manage those, especially with all those technical hitches?
Yeah, 17 experiments in total. One of the big successes was high-resolution photography for the Department of Defense. That was a key objective, and they got some good quality images. Of course, there were also the medical experiments. Those ran throughout the flight. They wanted to understand how long-duration spaceflight impacts the human body. And some interesting things came out of that. For instance, they found that astronauts had reduced appetites. They got dandruff, probably because of the low humidity. And after the flight, both Cooper and Conrad had lost some red blood cells and plasma, though they recovered at different rates. All this information was crucial for planning longer missions, like Apollo.
So even basic biology being investigated up there, what about other scientific work?
Well, Cooper, he managed to take the very first photographs of the zodiacal light and the Gegenschein from orbit. It's that faint glow you sometimes see in the night sky, sunlight reflecting off dust particles. And then they had a cloud talk spectrometer. They used that to successfully measure cloud height, all from space. And their geological photography, that was impressive. They captured a really detailed image of the Zagros Mountains, better than any existing maps. All of this, even with the technical challenges, really showed how useful crewed spaceflight could be for science, for studying Earth, for fundamental research.
It's a pretty good scientific return, but I'm guessing not all the experiments went to plan.
Sadly not, no. The fuel cell issues, well, those had a knock-on effect. And then on day 5, they had a major problem with one of their thruster blocks, part of the Orbit Attitude and Maneuvering System, OAMS for short. Thrusters 5, 6, 7, and 8, that whole block just kept failing. Couldn't use them at all. And that meant they had to cancel any experiment that needed those thrusters. Things like measuring the brightness of the sky, observing rocket plumes. If they could have done more photography of the RAP, that would have been off the table too. This thruster failure was a big reminder, wasn't it? Spacecraft are complex, and one little thing goes wrong, well, it can have a big impact.
Absolutely, a reminder of how delicate these missions are. Now, were there any other technical issues or just odd events during the flight?
Ooh, a few. Right at launch, they had something called pogo oscillation. It's where the engine thrust makes the whole rocket structure vibrate, like a pogo stick. Lasted about 13 seconds, peaked at plus 0.38 grams. That's more than they'd like. Conrad and Cooper both said their vision and speech were affected for a bit due to those vibrations. Turned out the problem was improper gas levels in an oxidizer standpipe. And then, something a bit strange. When they watched the film of the launch, they saw these flashes of light in the exhaust plume of the first stage. No one could figure out what caused it. Best guess, duct tape. Apparently, they'd used duct tape to secure some desiccant bags to an exhaust pipe.
Duct tape causing mysterious lights. Who would have thought? Anything else noteworthy on the technical side?
Well, the first stage of the Titan II, a rocket that launched them, that was fished out of the Atlantic. You can see it on display in Huntsville now. And then there's the landing. The Gemini 5 capsule landed about 80 miles short of where they planned. Now, the computer itself worked fine. Problem was they programmed it with the wrong value for the Earth's rotation rate. They used 360 degrees per 24 hours. Should have been 360.98 degrees per sidereal day. A sidereal day, well, that's the time it takes the Earth to rotate relative to the stars. Slightly different to our normal day. And over 8 days, that little difference adds up. You need those precise calculations.
A reminder that even with computers, human error can still creep in. Now, I came across something Conrad said about the mission. Something about a dustbin.
Chuckles. Ah, yes. Conrad, quite a character, famously said, 8 days in a dustbin, describing the mission. He was talking about the size of the Gemini capsule, of course. Tiny, like the front seat of a Volkswagen Beetle. And the sources mentioned other discomforts. They were cold a lot of the time, even though they tried to warm the cabin up. Sleeping was hard, even when they tried to sleep at the same time. And the stars, well, they were constantly drifting past the windows.
Yeah.
They found it disorienting. He actually covered the windows up in the end. All of this just shows how challenging those early long-duration space flights were. Physically, mentally demanding.
8 days in those conditions makes you appreciate what they went through. Before we wrap up, there were a couple of other interesting things I wanted to touch on. The mission insignia, for instance. Why a covered wagon?
Well, Cooper chose it. It represented the pioneering spirit of this 8-day mission. The original slogan on the patch was, 8 days or bust. NASA management, though, they weren't so keen on it. They thought it was a bit too much emphasis on the duration. Might look bad if they didn't quite make the full 8 days. So they actually sewed a patch over the slogan. Bit amusing, really. It's also worth noting that this was the first mission to have a patch like this. Cooper's idea. And if you want to see the Gemini 5 capsule itself, it's on display at Space Center Houston.
A little piece of history. And finally, you mentioned that the Department of Defense played a big part in this mission.
A huge part. They provided personnel, over 10,000 of them. They provided aircraft, ships, all essential for tracking the spacecraft, communications, and of course the recovery. They picked the crew up in the end, USS Lake Champlain. All these different organizations working together, it was essential in those early days of spaceflight.
So a really detailed look at Gemini 5. We've learned that it was a crucial mission, a success. It showed that long-duration human spaceflight, something essential for going to the moon, was possible. The fuel cells, despite those early hiccups, they worked. They had to adapt the rendezvous, they had technical challenges, but they still got important medical data, great photography.
Absolutely.
Yeah.
And it's important to remember how complex and dangerous all this was. From the launch to the landing, they had to overcome all these technical hurdles. It shows just how much ingenuity was needed in those early days of spaceflight. And everything they learned, it all fed into the next big thing, the Apollo program, Gemini 5. It played a vital role in getting us to the moon.
Absolutely. It makes you think, doesn't it? All those challenges, 8 days crammed in a tiny capsule, fuel cells acting up, thrusters failing, navigation problems, and then just a few years later, we put people on the moon. The audacity of it, the brilliance. That gap between Gemini 5 and Apollo 11, it's amazing to think how much we learned, how much we had to solve to get from one to the other. A fascinating mission, a crucial part of the story of space exploration.